My talk is about the challenges of ambient agents. I'm a developer advocate at Auth0, and background is in event processing. So ambient agents are particularly exciting for me. So if I say anything resembling a forward-looking statement, I have little inside knowledge, so disregard it. And so yeah, so framing the challenge. So you know, there's a lot of complexities and issues with copilots just reacting to prompts. And so when it comes to ambient agents, these issues magnify. And so we're going to be looking at what ambient agents are, why they're a problem, and how might we mitigate those challenges. So sustainability. Most AI projects fail. It's not even funny. And so like with the CAP theorem, you can just choose 2 of the 3 things and make your choices. But when it comes to ambient agents, they have to be fast enough to matter, cheap enough to run, and governable enough to trust. There's really no negotiables there. So any one of these will wreck your project. So Harrison Chase came up with the term ambient agents. These agents running in the background and listening to signals. So typically an event or something and taking action. And so that's quite different from the request response pattern of your chatbot. And so the fact that intent is no longer explicit is going to create a lot of problems. So we'll jump in there. So yeah, ambient agents must act whenever conditions arise. It could be tracking differences in logs, deployments, tickets, and if we think about the context window, the more context in there, the more ways to go wrong. So that's particularly a problem if you have agents with a kind of a wide purview and grabbing signals from everywhere and needing to take action. So they need a lot of help there. So they have to be able to interpret the noisy signals and really just get the minimal context that is that's valid. And then they have to be governable, right? When we have processes running in the code, someone has written that code, so we know what that code does. But with an agent, we know what we told it to do, but we don't know how it's going to do it. So as we'll see, determinism makes this a lot more tricky. So things boil down to the intent. It's now implicit. So it's not like a user asks for something and the ambient agent has to take action. It's based on looking at things over time, trying to remember what makes sense, and taking action. And again, the lack of determinism, and then the problem with authenticating and authorizing. So here's just a small example of how intent gets revealed. An agent's looking at your logs, and there's bad signals in there. Then it's going to go and correlate that with recent deployments. Okay, it sees something, it can take action, roll it back, notify Slack, open a channel. So that's kind of example. You're not going to have a bunch of if-then statements in there because it's going to be a lot more fluid than that. So it all comes down to context. That's why context engineering is so important. You're having your event streams coming in. They're raw signals. It's not like ready context for an agent to take hold of. And in that event, depending on what the underlying issue is, what parts of that context in that event may vary. So you have to basically build some kind of heuristics to understand for that state coming in and what that event seems to call for, what aspects of that context you pass in. We'll use things like aggregates, counters, and sketches to kind of reduce the amount of information coming in, so we don't actually, we just want to lose noise, but maintain all the vital signal. And then we want to present to the LLM a reasoning case. So clearly, connecting your AI agent to an event stream would be a very bad idea, especially financially, for your pocketbook. So how do we deal with continuous context? So yeah, that's a fire hose, and that's nothing you want to be spending tokens on. So we need to basically maintain efficient state and act fast enough to stay relevant. So what we're really looking at is that once you have an event bus involved, it's a stream processing problem. So all the tools we're using for stream processing to basically come up with real-time state, we absolutely need for an ambient agent to be able to make effective decisions in a tractable way. So one way to think about it is this context-aware governor pattern. You've got these raw streams, and we know the event stream is not sufficient, so we need code that can basically pull the context from that event stream, structure the states. So there's got to be stream state, because just a particular event is probably going to be missing important context. Just think of out of order messages, and sometimes it's a pattern of things, like this event might be okay normally, but if it was preceded by another event or followed by a different type of event, then that would be a very different thing. So it's a complex event processing problem. It's an event processing problem. So having some code in there to basically translate those raw signals and provide the agent actionable context is going to be what we're looking at. So yeah, imagine a fluid stream. So we're going to manage deltas, maybe at certain thresholds that will trigger an event, a certain accumulation of events. We basically need a way to emit at a much slower rate, but an actionable rate. Like once we've seen enough to get a better idea that there's something for the agent to do, that's when we need to pass it, and we need to basically also at that time be sure about the policies involved and what kind of information is in there, so that the agent only has what it's supposed to have and is only doing what it's supposed to do. So there's a lot of mechanisms for maintaining the stream state. We can look at windows, tumbling, sliding, and so forth to kind of aggregate from that slice to give the agent just what it needs in that moment. We could look at reducing the dimensionality with different kind of sketches to basically keep that stable space and just hold what's necessary for the agent to make the decision. Staple patterns, like I mentioned, complex event processing, joins, enrichments, whatever we can do to basically tame that payload, incremental aggregates, so counters, histograms, moving averages, those type of things, to basically enrich that event with the stream context, so that the agent will have more context. And then anomaly signaling, that's a big one, because we're going to surface deviations without full recompute. Basically, if there's an anomaly signal in there would be basically particular compensating actions that an agent would want to be able to take, and so want to be able to know about. So fortunately, there are a lot of tools for these things. We wouldn't be reinventing the wheel. So things like Flink for most all the things, but yeah, event time windows, incremental aggregates, complex event processing, solutions like Materialize for incremental views, stateful SQL, Red Panda because it's always super fast, and Kafka Streams, you can do some processing on top of it. You can do that with Flink too, of course. But yeah, Ktables, sliding windows. KSQL DB, again on the Kafka side, processing a lot of information, and none of that stuff takes tokens, so it's just what we want before we get in there. Fennel, Vector DB, FOSS, temporal patterns on the Python side. So a lot of different tools to use for this processing to basically tame that event stream so that it's going to be actionable for your agent. But if you don't want to do a high load and you say, okay, it's really basic, I don't want to be pulling in all this infrastructure, you can do more lightweight things with a lot of various libraries like Redis streams with Redis Bloom to kind of just do things in the runtime state of the agent. T-Digest, River Cream, especially with the quantiles, DuckDB, awesome library, and lots of sketches if you want to basically, which things you're trying to basically squeeze down. You could just directly use some sketches there. So let's get to identity and governance. Yeah, so, think about social engineering, right? I'm not going to say whether I've ever been had or not, but definitely there's lots of examples of AI agents being had, and it happens in various ways. For context engineering, manipulating log metrics, requests, signal pollution, poisoning the upstream text, context, altering windows. Feedback loop exploitation, repeating patterns over time, so the agent slowly shifts its definition of normal without noticing. It's like, boiling the frog slowly. Emergent intent hijacking, shaping events so that the agent believes, something else is happening. Dynamic boundary manipulation. So there's all kinds of different ways, because you could say, yeah, we're not worried about someone hacking in and talking to the prompt, but there's a lot of ways to basically get things into the event stream that your agent will see, and so there's still an attack surface to deal with. So there are a variety of ways of manipulating an agent's perception, but you can't trick a scoped access token. So that's why we want to be able to rely on security protocols and identity and access management. So Auth0 for agentic governance is basically, we need to know, if we think back in terms of RAG and all its kind of evolutions, we started with basically large language models and their training data, right? Ask it all kinds of things, ask it to do all kinds of things, and it can do it, right? But when it comes down to your company's information, real-time events, it had no answer for you. But it would give you an answer and be very sure about it, but it doesn't really actually have a real answer for you. And so, we had all these different RAG approaches to come up with how do we bring just-in-time context to give the agent that information. Now, when we're looking at agents doing things for humans, for users, and users that have a bunch of different applications, and their data split across those applications, the different silos, this is definitely a case where we, again, need to have a way to kind of pull in the right context. But this gets very dangerous because you are hitting your users' applications, and if you give that agent the credentials to that user, all sorts of things can happen. And so you need to basically be able to make sure for the agent what user they're talking to, and then a clear way about creating short-lived access based on what the user is trying to accomplish and what they want to do. So identity is a big part here, and then the governance being able to define things like the fine-grained authorizations and other kind of policies that you have, and then the ability to enforce it with on the security side with PKI and other type of methods. So, identity determines who can act. So your agent might have an identity, but that identity, if it's working on behalf of a user, also has to take into account that specific user you're acting for. And it's not, it's not that that agent can, if you think about how intent merges over time, and it's not explicit then, if you take the same agent and the same logic and the same trainings, but if it's been dealing with me over time, that agent is really going to be a different agent than the same agent that's doing something for someone else. So there's going to be drift, and there's going to be basically what the agent has learned. And so really, identity at this point becomes a compound concern of the agent and who they're acting on behalf of. And then on the governance side, when it comes to the user's data, what they're granting access to and on what terms, and then how do we manage it? Like every time if we ask the agent to do something, it gets more permissions and it keeps accumulating, then it's going to be the same thing as if you gave it credentials at the end of time. So things have to be scoped and short-lived, and you also need to be able to partition your permissions so that the agent at any time doesn't have wide-range access to do completely unrelated things and basically have a wide surface to expose to an attacker. So agents must act on behalf of users, so identity and delegation matter. Without access control too, you will lose context about who did what, when, and why. And so it's another reason that on behalf of user has to be part of that compound identity. So there are various ways to protect against a lot of these things. You'll see cases where people have gotten illicit access to databases, pulled down a lot of records that they shouldn't have been able to see. So finding fine-grained access control is one way to, instead of just having these very coarse permissions, you'll be able to say things like, okay, this person has access, but not from an unknown IP address, or not outside of work hours, or not from a different location, or not if a certain type of case isn't open. So there's really a rich range that you can do for your domain and your model so that a lot of those rules will protect your agent when it's basically getting scammed to do something that it shouldn't do. It'll go ahead and try it, but such permissions will limit what it can do. That's undesirable. And then sender constrained tokens, right? If your tokens are stolen, normally someone is going to be able to impersonate your agent and go ahead and do lots of bad things, right? So by using sender constrained tokens, like with Depop or MTLS and methods like that, you're basically having all the subsequent requests backed by a private key so that if the attacker doesn't have that private key, then even though they've stolen the token, they won't be able to do anything with it. Again, being able to keep the user in the loop with async auth, use things like the client-initiated backchannel where you can push approvals to the user's phone so that they can kind of see what the agent wants to do. It wants to do like maybe a Stripe transaction and verify whether you want it to go through. And token vault I mentioned, you have all these different apps of the users. None of those credentials should go into the agent, right? That's just a big risk. It's going to be, if that agent is gotten, then there'll just be all the things that they can do with your information and your identity. So with token vault, what it lets you do is that it holds those credentials, and then when the agent needs to take action, the user can kind of authorize in a more of a fine-grained way, what they want to do. And so you don't have, everything exposed at once. And then again, keeping things minimally scoped and not just accumulating permissions over time, but revoking ones that are no longer needed for ongoing tasks. So if we go back to that governor pattern, And now that we have some ways to kind of enforce it, it looks a little bit different. We have the external signals, we have the user's data involved, and so you'd have the governor basically managing that context as the signals are coming in and packaging, an actionable case for the ambient agent, and then the ambient agent is now governed by identity and access control, and then to be able to call the external APIs. Now, there are also some complementary solutions that I'd like to mention really quick. There's, behavioral policy enforcement, things like Marshmallow AI work on that. It's totally complementary. There's prompt-based security, something like Mill Pond Research. So all together, to get a complete picture, we'll take a quick look at that. So for complementary solutions from Marshmallow AI, we've got behavioral policy and learned norms. So, it's using reinforcement learning, kind of student-teacher patterns, so things like continuing inferring normal agent behavior from real action traces, the student-teacher model where your agent is the student, and then there's other kind of context from the teacher to observe that, okay, this makes sense, this is correct, and that it reflects what's been done over time, and it reflects policy. And it actually adapts over time so that it gives consistency there. And so norm discoveries, it spots repeated behaviors across similar situations and highlight which ones match what people consider good. Adaptive behavioral patterns, the system automatically tightens or loosens what actions the agent is allowed to take. And then, working with the existing identity permissions. Identity rules decide who's allowed to act. So FGA, Auth0, other solutions. So it's very pluggable that way. Mill Pond, too, has a solution where now you're going to say, this is for like prompt-based attacks. And if we're talking about ambient agents, you'll ask me, okay, why are we talking about prompt-based attacks? Prompt attacks can still appear in the event layer. How you handle prompts and how those come into events should be very intentional. You'd never want to just basically expose those prompts. They should go through other processing and policies before doing so. But then the other thing is that even with that taken care of, when your ambient agents are talking to other tools, talking to MCP servers, here's still a case where that communication, those requests going to those tools, can also have non-normative behaviors in there that these tools can look at. So basically, it gives a visibility into every agent query, delivering insights and optimizations. It intercepts these calls to determine which ones are allowed. And so it will proactively block them. Now, sometimes it's actually benign, like, okay, someone has made a dangerous request, but they're not trying to do something illegal, and so it will go ahead, in some cases, to kind of mask and patch those so that the call can actually go through. And then, it's interconnecting all the prompts and agents so that you kind of get this nice behavioral layer in there, so. So an interesting thing is that a big thing we want from AI generally is to scale people, right? Scale the workforce. You can say, okay, we want to reduce the workforce, or we want to make people more powerful. And so we give agents tasks to do things, and we give them credentials. And so if you give a human a wide range of APIs and a wide range of permissions, the human will basically use the ones that it takes to do the task. A human has some kind of normative understanding, or they can know that they can get in trouble or whatever. Agents are different. All the tools you give to the agent can use in very novel and surprising ways and take full range of that thing. And so if you think about it, you want to automate tasks that people have been doing correctly over time. So you probably don't want a lot of random and novel solutions generally. I mean, sometimes it's good, and we can capture those, but you want to be able to basically learn from that audit history and make that enforceable, within your auth system, like using something like fine-grained access control, fine-grained authorization. So that's what we're looking at here, like deriving norms from audit history and making them governable through things like FGA, and then making them accountable. And this is a case, before we talked about where AI agents are doing things on behalf of users, but here the ambient agent is having a boss, just like the other people doing the work. And so if an agent is doing things where it's used an uncommon set of permissions, it's trying to call an uncommon set of APIs, then this is a chance where it can get stopped, have to basically explain itself, request authorization from a user, and then if it so happens that that is valid, it can go through, and then otherwise, it will get blocked. So it's a way to kind of scalably utilize your audit history when you're letting agents take on work that humans have done in the past. So that's, making norms enforceable. And I think that's really the main thing there, is that basically creating this loop where we can let the agents learn from the humans, and then the humans learn from the agents in the case where agents make breakthroughs. So I think that's good here. And thank you very much.
So we do have time for a few questions. Anybody has any questions?
The real question is, what's for lunch?
Yeah, probably. Thank you so much, Fred. I appreciate this.
Thanks, everyone.